Hello viewers, today we will again discuss the pharmacokinetic overview of the drugs, and for today's session our learning objectives are that by the end of the session you will be able to discuss the water solubility and the fat solubility of the drug, that what is actually the water solubility and the fat solubility, and what is actually the clinical importance of water solubility and fat solubility. Another objective is that you should definitely be able to understand and discuss the bioavailability of the drug and the first pass hepatic metabolism of the drug, or the first pass effect of the drug. Our third objective is definitely the absorption and the factors which affects the absorption. So these are our four learning objectives of today's session. The pharmacokinetic of any drug has four well-defined mechanisms or the processes. On the top, there is absorption, that the drug from the route of administration it gets absorbed, and then when it is absorbed, it is in the systemic circulation, it should be distributed to the peripheral tissues and to reach the site of action for the proper action of the drug. And when it distributes, then it goes to the liver and other organs for the metabolism, and after metabolism the drug gets eliminated out, that is the elimination. So these are the four different mechanisms, we call it as the pharmacokinetic mechanism, and the total pharmacokinetics of any drug depends on these four mechanisms. When the drug is administered in the body, it definitely faces and crosses through different barriers, and that barriers today I will discuss the two extremes of the barriers. This is actually the blood-brain barrier. This is the endothelium of the nervous tissue, and this is the blood. So what you are going to see in this blood-brain barrier, that there is no silt junction, that is the continuous, you see, the barrier, cellular barrier, epithelial barrier, and these are the tight junctions, but there is no silt junction. So what is the clinical importance? Clinical importance is that the drug which reaches from blood to the brain has to cross these cellular membranes. So only the fat-soluble drugs, they could cross this barrier, reaches into the central nervous system, while the water-soluble drugs, they couldn't cross this cellular membrane, so they could not get access into the central nervous system. What is the another extreme? This is the epithelium of the liver. And what you are going to see in this epithelial lining of the liver, that there are all the gap junctions, the big gap junctions. So each and every type of a drug gets entry through these gap junctions into the liver hepatocytes for the metabolism, whether the drug is water soluble or the lipid soluble. Now question arises that what is actually the water solubility and what is the lipid solubility, or what are the water soluble drugs and what are the lipid soluble drugs. This solubility is totally depending on the pH, and there are two pHs, the pH of the drug itself and the pH of the medium where the drug reaches and get access. Now this is actually the medium, that if the route of administration is the oral, so this is the medium, that is the gastrointestinal tract, that is the stomach, and this is the lower part of the intestine. So there is a big range of the pH in such sort of medium, that the pH of the stomach is 1.2 to 2, and the lower part of the small intestine, the pH is 6.6 to 7. So that is the extreme acidic to the extreme basic pH of the medium. Likewise, the drugs, there are two types of drugs, the acidic drugs and the basic drugs, depending on the pH of the drug itself. So this is again the medium, and we know now that this medium is the stomach and the pH of the medium is acidic. And if the drug which is acidic reaches into this medium, now this drug is a charged drug. A for the acidic, and the acidic drug is a charged drug. And it is the chemical property of this acidic medium that when any drug reaches in this medium will donate the protons. So what happens? That when acidic drugs, then these protons, they all get attached with this acidic drug will become uncharged. Any drug which has the charge, it attracts the water molecules, so we say that the charged drugs are always water soluble, and the uncharged drugs, they are fat soluble. So in case of the acidic drugs, we can say that the unprotonated form of the acidic drug is charged, so the unprotonated form of the acidic drug is water soluble, and when the protonated form of the acidic drug is uncharged, so this is the fat soluble. Total, the story is reversed in case of the basic drugs. Medium is same, that is the stomach. The pH is same, that is the acidic. But the pH of the drug is totally changed. Now the drug is basic. And what is the difference between the previous acidic drug and this basic drug? That this unprotonated form of the basic drug is uncharged. That is the fat soluble. Now what is the property of this medium? It will donate the protons. And when this basic drug get attached with these protons, or we say that this protonated form of this basic drug, it will become charged. It means it will become water soluble. That is from fat soluble to the water soluble. So the same drug, when goes down, and this is the summary of this at the stomach level, that this is the acidic drug, which is a charged drug, and when these protons, they all get attached with this acidic drug, this protonated form of the acidic drug is uncharged. This form of a drug is the water soluble, and this form of a drug is the fat soluble. This is the basic drug. Unprotonated form of a basic drug is uncharged, means the fat soluble, and when the proton gets attached with this basic drug, the basic drug will become charged, so the protonated form of a drug is water soluble. When these drugs goes down in the lower part of the intestine, that is the big change in the pH of the medium. Now the pH of the medium is alkaline, and what is the chemical property of the alkaline medium? That it will accept the proton. This is the uncharged fat soluble form of the protonated form of the acidic drug. When it reaches into this alkaline medium, what this medium is doing, that it will accept the protons. It will accept the proton, and finally the drug, that is unprotonated form of the drug, of the acidic drug, it will again become charged, that is the water soluble. Again, the story is totally reversed in case of the basic drugs, because the protonated form of the basic drug is a charge, is the water soluble. Chemical property of this medium is to accept the protons. So what happens when this basic drug loses the proton to the medium, and this basic drug unprotonated form of the basic drug will become uncharged, so it will become a fat-soluble drug. So what is the conclusion? Conclusion is that the maximum absorption of the acidic drugs are from the acidic medium, and the maximum absorption of the basic drugs, they are from the basic medium. That we will discuss later on in a coming session of the distribution. So this is actually the pKa. pKa, and all the students, majority of the students, they definitely do the mistake that when anybody is asking about the pKa, they say, so it's the pH of a drug. So never, it's not the pH of a drug, but it is actually the pH of the medium. At the pH of the medium, that half of a drug is the protonated form and the half of a drug is an unprotonated form. So this is actually, and this is a constant, we cannot change it, and this is actually the portion of the pH of the medium from where the maximum drug gets absorbed and distributed. We will further elaborate the clinical importance of this pKa and this protonation and the unprotonation form of two drugs in coming session when we will discuss their distribution and elimination of the drugs. So this is the clinical importance of this, and this is actually the background of this water solubility and the fat solubility of the drug. Now, the very important mechanism of the pharmacokinetics. The pharmacokinetics starts from the absorption. They're very important. And what is the absorption? That if the drug from the route of or the site of administration, it crosses the semi-permeable membrane and reaches into the systemic circulation, this whole process is called simply as the absorption. So, if the drug is administered through the oral route, it goes to the GIT, that is the stomach, and from the stomach, first it goes to the portal circulation, and then it reaches to the liver for the metabolism, and we call it as the first pass hepatic metabolism, and the portion of the drug gets metabolized and excreted out, and the portion of a drug which is in a chemically unchanged form get access into the systemic circulation. For example, suppose we administer the 100 milligrams of the drug through the oral route of administration. It reaches to the stomach, then it goes to the portal circulation, then it reaches to the liver, and in the liver, the 20 milligrams of the drug, they get metabolized, they chemically change their form, and the 80 milligrams of the drugs, which is chemically unchanged form, it get access into the systemic circulation. So this is the portion of the drug which is wasted by the first pass hepatic metabolism. We call it as the extraction, and the portion of a drug which is in a chemically unaltered, unchanged form, that we call it as the bioavailability. If the extraction of the drug, if the first pass hepatic metabolism of the drug is more, definitely the bioavailability will be less. If the extraction or the first pass hepatic metabolism is minimal, then we will achieve the very efficient bioavailability of the drug, because the total effects of the drug, they depends on this bioavailability. So there are certain type of drugs which have more than 90% of this extraction ratio, more than 90% of this first pass hepatic metabolism. So what is the way out? We could not afford the big loss of the drug clinically and socioeconomically. So what is the way out? Way out is to change the route of administration from oral to the intravenous. If we go to the intravenous route of administration, the drug will directly reaches the systemic circulation, and it bypasses whole this portal circulation and the first pass hepatic metabolism, and we can definitely avoid this major extraction of a drug. Like the drug like sodium nitroglycerin, that the extraction or the first pass hepatic metabolism is more than 90%, and just we get the 10% of the bioavailability of the drug. We could not afford the 90% or more than 90% wastage of the drug, so we changed the route of administration. We changed from oral to the sublingual route of administration, because the sublingual route and the intravenous route, they bypasses the first pass hepatic metabolism, so the drug's bioavailability will be the maximum. In case of the rectal, in the rectal, that we have the 50% avoid, we just avoid the 50% of the first pass hepatic metabolism. Now, if the drug is administered through the intravenous route of administration, then what happens? The drug will reaches directly into the systemic circulation, and it bypasses the whole this process, that the drug could not cross the semi-permeable membrane, and it directly reaches into systemic circulation. So what happens? So what we have learned now, that what is the absorption? Absorption is actually the movement of the drug from the route of administration. It crosses the semi-permeable membrane and then it reaches to the systemic circulation. So it bypasses. If the route of administration of the drug is intravenous, then what happens? That there will be no absorption of the drug. The drug will escape the very basic mechanism of the pharmacokinetics of any drug. So if the same drug is being used through the oral route and through the intravenous route, the pharmacokinetics of the same drug is totally being changed. And we must assume that the kinetics that starts from the absorption, distribution, metabolism and elimination, but now we can say that all these four processes, they totally depends on the route of administration. If the route of administration is the oral, the kinetics is changed. If the route of administration is the IV, the kinetics is changed. So now we can change our the scenario that the pharmacokinetics doesn't start from the absorption, but it's really and actually starts from the route of administration. And these are actually the factors. There are so many factors, but here we will discuss the very important factors, and that they are very important, and all these processes, the absorption, they totally depend on this factor. The most important is the solubility. What I do mean by the solubility? Solubility means, right now we have discussed about the drug solubility, whether the drug is water soluble or the fat soluble, and definitely complete absorption or the movement of the drug across the membrane depends on this nature of the solubility of the drug. And that is the surface area. The more the surface area, the more the drug will crosses the membrane and then reaches into the systemic circulation. So this is another factor that is directly proportional to the drug movement. The third one is the vascularity. More the vascularity, the more the drug will reaches to the systemic circulation, and the vice versa. And the final is the concentration gradient. That is, what is the difference in the concentration between the two compartments. So this is the concentration gradient, and these are the four very important factors that contributes to the complete absorption and further distribution of the drug. Thank you very much.